Morning class. Today we are going to have a video lesson for our synchronous class, and we are going to focus on the midpoint of a line segment in a Cartesian plane. Let us have a quick review. What is 6 plus negative 5? The answer is 1. How about 7 plus negative 15? If your answer was negative 8, then you are correct. What is 16 plus 11? The answer is 27. How about 6 plus negative 21? The answer is negative 15. How about negative 5 plus 11? The answer is 6. What is the sum of 5 and 11? If your answer was 16, then that's perfect. Now let us talk about the midpoint of a line segment in a Cartesian plane. Main and Teresa are planning to study together, but want to be fair with travel time. Using the coordinate grid, help them find the exact halfway point between their homes. Main's place and Teresa's place are horizontally aligned. So let's count how distant they are from one another. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So they are 14 meters away from each other. So dividing that by 2, each of them should walk 7 meters. 7 meters from Main's house will end at this point, and Teresa's walk 7 meters towards the left will end up at this point. And that point is 1, 1. Therefore, Main and Teresa will meet at 1, 1 on our Cartesian plane. That point is what we call the midpoint. Using the figure, the point where Main and Teresa will meet, which is at 1, 1, is called the midpoint of the segment connecting their houses. Think about this question. In your own word, how do you define midpoint? In a bookish definition, the midpoint is the point that lies exactly halfway between two other points. It's like the center point that splits the distance evenly between them. The midpoint of a line segment is a point that divides or splits the segments into two equal parts or lengths. To find the midpoint of a line segment, given its two endpoints x sub 1, y sub 1, and x sub 2, y sub 2, the formula for the midpoint is x sub 1 plus x sub 2 over 2 for the x coordinate, and y sub 1 plus y sub 2 divided by 2 for the y coordinate. Let's have an example. Find the midpoint between the houses of Donna and Teresa. Let's have the midpoint formula, and let's substitute the coordinates of the points. So Donna is at 3, 6. So let's count those coordinates as x sub 1 and y sub 1 respectively. Whereas x sub 2 and y sub 2, which is Teresa's coordinates, will be 8 and 1. Substituting both to the midpoint formula, we will have 3 plus 8 divided by 2 for the x coordinate, and 6 plus 1 divided by 2 for our y coordinate. And we will have 11 over 2, 7 over 2 for the y coordinate. Therefore, the midpoint is at 5.5 or 3.5 in decimal form. Let's have another example. Find the midpoint between the houses of Abby and Maine. First, we have to identify the coordinates of each point. Abby's house is at negative 2, 4, and Main's house is at negative 6, 1. Substituting those coordinates to our midpoint formula, we will have negative 8 over 2, 5 over 2. Negative 8 divided by 2 is negative 4, whereas 5 divided by 2 is 2.5. Therefore, the midpoint is at negative 4, 2.5. Let's now try to find the midpoint between the houses of Teresa and Hanji. Using the midpoint formula, let's substitute the coordinates of their houses. We will have 8 plus 3 over 2 using their x coordinates divided by 2. And we will have 1 plus negative 7 over 2 using their y coordinates divided by 2. Simplifying, we will have 11 over 2, negative 6 over 2. 11 divided by 2 is 5.5, whereas negative 6 divided by 2 is negative 3. Therefore, the midpoint is at 5.5, negative 3. Now let's find the coordinates of the midpoint given the two endpoints of the line segment. This is the one that we will use if we don't have the Cartesian plane in front of us, but we have the coordinates themselves. We can just put those coordinates in the midpoint formula, and we will get 6 over 2, 10 over 2. Simplifying, we will get 3, 5 as our midpoint. How about 3, negative 1, and negative 5, negative 3? What is their midpoint? Substituting to the midpoint formula, let's get the x-coordinates. 3 plus negative 5 divided by 2. For the y-coordinate of the midpoint, let's have negative 1 plus negative 3 divided by 2. 3 plus negative 5 is negative 2 divided by 2. For the y-coordinate, we have negative 1 plus negative 3, which is negative 4 divided by 2. Simplifying, we have negative 2 divided by 2 is negative 1. Negative 4 divided by 2 is negative 2. A line midpoint negative 1, 0 has an endpoint of negative 4. What is the other endpoint? In this example, we are now missing one of the points, not the midpoint itself. So how will we use the midpoint formula to find the other endpoint? Simply put, we just have to use the same formula for the midpoint, except instead of missing the midpoint, we will have the x coordinates and the y coordinate plugged in, and we'll be finding the x sub 1 and y sub 1 respectively. So for the first one, since we know that the midpoint is negative 1, 0, the x coordinate of the midpoint is negative 1. So we put that in the place of negative 1 of the m, and then we find x sub 1. Using cross multiplication, we will have negative 1 times 2 equals negative 4 plus x sub 1. Simplifying, we will have negative 2 equals negative 4 plus x sub 1. And transposing to the other side, we will have negative 2 plus 4 equals x sub 1, which will simplify as x sub 1 is equal to 2. Now, for the y-coordinate of the other endpoint, let's use the midpoint formula and plug in 0 for the place of m. 0 equals negative 3 plus y sub 1 over 2. Using the cross multiplication, we have 2 times 0 equals negative 3 plus y sub 1. 2 times 0 is 0. And then transposing negative 3 to the other side, we have 0 plus 3 equals y sub 1, which simplifies as y sub 1 is equal to 3. Therefore, putting these coordinates together as an ordered pair, the other point is at 2, 3. Let's have another example like that. A line segment whose midpoint is 4, negative 5 has an endpoint of 1, 7. What is the other endpoint? Solve for the x-coordinates of the other point. Since we are looking for the x-coordinate, we will plug in the x-coordinate of the midpoint in place of m. So we have 4 equals 1 plus x sub 1 over 2. Using the cross multiplication, we have 2 times 4 equals 1 plus x sub 1, which translates to 8 equals 1 plus x sub 1. And 8 minus 1 is equal to x sub 1 using the addition property of equality. Now, 8 minus 1 is equal to 7. Therefore, that will be our x-coordinate. How about the y-coordinate? We had to plug in negative 5 in place of m to find the y-coordinate of the missing point. we have negative 5 equals 7 plus y sub 1 over 2. Cross multiplying, we have 2 times negative 5 equals 7 plus y sub 1. Negative 10 equals 7 plus y sub 1. And transposing 7 to the other side, we will have negative 10 plus 7 equals y sub 1, which simplifies as y sub 1 equals negative 3. Putting them together as an ordered pair, we will have 7, negative 3 as the coordinate of the missing point. Our main takeaway from this presentation is that the midpoint of a line segment is a point that divides or split the segment into two equal parts or lengths. And to find the midpoint of a line segment given its two endpoints x sub 1, y sub 1, and x sub 2, y sub 2, the formula is m equals x sub 1 plus x sub 2 over 2 for the x coordinate and y sub 1 plus y sub 2 over 2 for the y coordinate. Now it's your turn. Pause at this moment and try answering these questions. Find the midpoint between each pair of points. Also, given the midpoint and an endpoint, find the missing endpoint of a line segment given these information. Here's a set of problem solving so you can also work on your reading comprehension while applying what you have learned about midpoints. Thank you so much, class, and let us resume our face-to-face classes and answer those questions together.